All right, let's see if this now works. So I'm not sure how much the stream, when the stream cut out, but this is the problem we are working on. And to find the domain, we realize the domain for x, which is a polynomial, right, is everything. And domain for tangent x from negative infinity to infinity is interruption at every pi over 2 plus pi. But since we are restricted to the domain from negative 3 pi over 2 to 3 pi over 2, the domain you see below. Now, vertical asymptotes are also at the end points, right? 3 pi over 2. Range is everything. X-intercept, Y-intercept, and there they are. Now, look what I said for the X-intercept. You have to solve x plus tangent x equals 0. And in order to solve that, well, first we see x equals 0 is a solution, right? Because tangent of 0 is 0 and 0 plus 0 is 0. That's a trivial one. The other two are trickier to get. The other two you can't get by analytic methods. You can't solve that equation because you have two worlds meet, two different worlds that are not compatible for calculations. The one world is the world of trig functions and the other world is the world of polynomials. So transcendental functions don't mix with polynomials to solve equations. You can also see equations like e to the x equals to 3x plus 1. You can't solve that one using analytical methods. There is a very powerful thing you learn in Calculus 2 called power series that you can use to solve this, but that's Calc 2. There is no way for you guys to solve this in any other way other than graph these two functions. So the way to find these two more, right, the additional two x-intercepts, is to actually write this equation here as, let's say, tangent x equals negative x, and you graph that on the same coordinate plane and you read the solutions. So tangent x will have this like that, and x would go like this. So that's the only way. Now, how do you know? Well, see, the next one intersects, right? So the next one will go like this. And that's the intersection, which is this point here. And the next one over here will go like that, having this value as x-intercept. So this is your x2, this is your x1, whatever those values are. Now you see it's pi over 2 and so on. So I would say like negative 1.6, negative 1.7, something. Negative 1.8 and positive 1.8, something like that. So you have to actually get those using technology. There is no way for a Calculus 1 student to actually calculate that on the... now, what else you can do? You can do linear approximation, right? You can do linear approximation on that one, find the tangent line, find all of those kind of things and do that that way. Sure, you can do that. Yeah, but again, that's only if you're on desert island with nothing else to do. So we do have 3 x-intercepts. We have 4 vertical asymptotes, 2 are at the ends. No horizontal, no slant, and then we need to calculate now first derivative equal to 0. So derivative of x is 1, plus derivative of tangent is? Very good, equal to 0. So the question is, when is the secant squared x equal to negative 1? Well, there is the issue, right? You have a square equal negative 1, right? So no solution, right? So no solution, which means that this will have, we will not have any critical points. So no min, no max. We can still do the first derivative test because we have a lot of partitioning happening here because of the vertical asymptotes. You have the end one, 3 pi over 2. Then you have the pi over 2. Then, sorry, negatives. And then you have the positive ones. Right? So now you pick values in between. I'm going to pick negative pi, 0, and pi because I'm simple. You like pain, obviously you will pick something terrible. And we compute these at the derivative. Right? So the first derivative, we have f prime at negative pi. That's 1 plus secant squared of x. Well, I don't care what secant squared is because that thing is either, it's going to be squared, right? Plus 1. So they're all bigger than 0. They all have to be bigger than 0 because you have square number plus 1. Every square number is immediately positive. Plus 1 remains positive. So all of these are increase. All of them. Which you expect. It's a tangent, right? It has to look something like this and then a little bit skewed because of this. All right, cool. Second derivative equal to 0. Well, now the derivative of 1 is 0, and the derivative secant squared is 2 secant x, and then the derivative of the inside, which is another secant x tangent x. Good. So the second derivative is equal to 2 secant squared x tangent x. Ooh, we need to set that equal to 0. Now, clearly, from there, the points, right, are at pi, negative pi, and 0, just by looking at the equation. So, how do we solve this? Well, 2 is irrelevant. So tangent gives a sine in the numerator, so we have 2 sine x divided by cosine cubed, right? Because you have 2 cosines from secant and 1 cosine from tangent. When you cross multiply, cosine dies, so it's just 2 sine x equals 0. Divide by 2, you just have sine x equals 0. And sine is 0 on the domain that we have at negative pi, 0, and pi, because we are restricted to the domain. So those are our values for inflection points. Now look at the second derivative test. We have negative 3 pi over 2, which is the asymptote. Then we have a partition at negative pi. Then we have a partition at the next asymptote, which is negative pi over 2. Then a partition at 0 because that's the inflection. Then another partition at pi over 2 because that's the asymptote. Then another partition at positive pi because that's the... You get the idea, right? So now test points are in between. Let's start with 0 one way and then we'll just mimic to the other side. So what's halfway between 0 and pi over 2? Pi over 4, 3 pi over 4, 5 pi over 4. Negative pi over 4, negative 3 pi over 4, and negative 5 pi over 4. Tattoo this one. Yeah.
I mean, how much is an A worth to you? Some skin and like what, maybe like $40.
So f prime.
Get it in back alley.
Maybe if you go to prison, you can get it for free.
When you go to prison.
I have ink, I have needles, I can do it myself.
Yeah.
Oh, it's getting worse. All right, let's go. We have the first point is negative 5 pi over 4. So, guys, we have 2 times something squared times tangent x, okay?
Oh,
What's going on now?
the longest part of your number line too. Oh,
It will show maybe. So number 2 is positive. Blah squared is positive. I don't care what it is. So technically everything falls into what's happening with the tangent, right? So if tangent is positive, then I multiply 3 positives. If tangent is negative, it's negative, right? Now 5 pi over 4. All students take calculus, right? So 5 pi over 4 is in the third quadrant, so it's positive, larger than 0. So over here, is going to be concave up. I gotta fill the stuff that disappeared for whatever reason. It's a magic tablet, you know. And then let's see the next one. Negative 3 pi over 4. 3 pi over 4. We still have positive times the positive and then times the tangent of negative 3 pi over 4. Negative 3 pi over 4. So, oh wait, hold on. This is less than 0. Because the negative goes in front, right? This negative, it's an odd function. Negative jumps in front, and then tangent of pi over 4 is positive. So this is concave down. See? So now I have the same situation. I have positive times this negative is going to jump out, but it's a negative there, so I have a positive times a positive times a negative times a negative, and that's larger than 0, so it's concave up. Again, the negative will jump out, and that's the negative here. Next, it's going to be a pattern, they should alternate. Negative pi over 4 is equal to, again, positive times a positive times a negative times a positive, less than 0. Concave down, concave up, concave down, concave up. So awesome. And that should be clear, because when you draw a tangent, you see that if you are to end this side, it's a concave down piece, and this is concave up. So they have to alternate in between. All right, cool. So let's graph. I will put pi to be 4 squares. So I'll need 6 squares each side. 2, 3, 4, that's the pi. And then this is a 3/2, which is the end of the road. 1, 2, 3, 4, this side is a negative pi. 1, 2 is negative 3 pi over 2. So those are my pi divisions left and right. And now I have a 0, 0 point where function goes through. I have vertical asymptotes, right? So there are vertical asymptotes at the edges, and there are vertical asymptotes at pi over 2. There we go. We have no min-max values. We have x-intercept here. And then we also said that we have the x-intercept when the tangent What was that x-intercept? I drew a little graph on the side right here. So this is pi over 2, negative pi over 2, and positive pi over 2. So when we set that equal to 0, so they're close. I'll just put them here and here. So what do I have? I start with concave down and increasing, right? And then we switch to concave up and follow the asymptote. Concave down, concave up, concave down, concave up. Observe that both x and tangent x are odd functions. This has to remain symmetric on the y equal x line. If you draw a y equal x line, you will see it's symmetric. So that's 4.3, guys. The shopping list right there on the board. Domain, range, x-intercept, y-intercept, vertical asymptote, horizontal asymptote, slant asymptote. First derivative equal to 0 for critical points. First derivative test, increase, decrease, and min max. Second derivative equal to 0 for inflection points. Second derivative test for inflection points and the concavity up and down. And then if you need extra points, you calculate those. If you need even and odd to help you out, you can do that as well. So 13 items on the shopping list, one by one. And the more you practice these problems, the faster you will get. That's how it goes. But you've seen that, you know, we technically have the algebra, pre-calculus 1, pre-calculus 2 for trig functions, and then first, second derivative, and the tests, right? Min, max, all of it. So technically all you learned, right? You apply these log functions, e functions, trig functions, and also polynomial functions and rational functions. Square root function as well. So we didn't do any square roots. Try square root function. So that takes care of this section. The video stream is broken into 2 videos. So I'm going to stop this and restart for the